solve something like this, we're going to need to get the x by itself. So I'm going to have to undo or get rid of the 13 and ultimately the 5, which is next to the x. As a general rule, it's useful to do the order of operations in reverse. Now, in something like this, it's not quite as intuitive because we're doing 13 minus 5x. So it seems like we're doing a subtraction. We're subtracting the 5x. But really, what we're talking about here is getting rid of the 13. Okay, so I'm going to use subtraction before I use the addition, but it might not be the one that you're immediately thinking of. And that way, when I get rid of the 13 here, I'm going to have the x by itself with just the 13 cancels. I get minus 5x is equal to 68 minus 13 is 55. Much simpler now that we get rid of that 13 and we take it off of both sides. Now I'm going to divide both sides by negative 5. If I divide both sides by negative 5, I end up with x is equal to 55 over negative 5 is negative 11. X equals negative 11. Let me just do a quick check. So I shall take my negative 11, plug it into the original equation, and that's going to give me 13 minus 5 times minus 11 is going to be plus 55. And yes, 13 plus 55 is equal to 68, and it does work out. So the main point that I want to make with this is that when you're doing your reverse order of operations, which is a good general way to think about it, think about what you're actually trying to eliminate. We want to use addition and subtraction first in terms of eliminating elements of one side of the equation, but it would not be as useful if I added 5x to both sides, because that would simply displace the problem rather than getting to the heart of it. So we want to take care of or get rid of the constant term out here first. Hope that helps. Thank you. Thank you.